Good evening, morning, or afternoon. Welcome to the webinar on closing the trust gap for DevSecOps. My name is Jason Stout. I'll be joined by Dave Roche, product manager from our code signing practice here at DigiCert. So I'll just give a brief introduction and hand things over to Dave. So we're all here to learn. This is a learning environment. And so one of the things that I wanted to go ahead and advance the slide, Dave, is we're at the 20-year anniversary now of a regulation here in the United States called Sarbanes-Oxley. And I thought that was an interesting starting point, as Sarbanes-Oxley was a fraud-focused legislation that essentially corrected for large organizations and having their C-level executives being aware of what's happening under their own nose in their own organization. And now, we've moved past that into a new kind of challenge for the economy, which is around digital trust. And that trust focus is so much harder. Next slide, Dave. As we look at ecosystems and supply chains, in business now, I was comforted by something I read last week as I was preparing for this meeting. It's a Tech Target article, and I'll put the references here in the chat in just a moment. But by 2026, 50% of C-level executives will have performance requirements related to risk built into their employment contracts. That's something I learned, and I thought it was really poignant to bring up today, because as we've all been hearing different iterations of trust and zero trust, trust nobody. We need to build trust. It's become very difficult to really understand where we're going with this, but and really, is the investment going to come? And I thought that was a very, meaningful article. A couple other things that have been on my reading list, and I hope you will share yours as well, is a couple of books here. One is a book by Admiral James Stavridis. He's retired U.S. Navy, and the name of the book is 2034, a novel for the next world war, which really talks about the brewing that's going on in cybersecurity and risk and the challenges that lie ahead. Another book, the book I'm reading right now is by Stephen Covey Jr. called The Speed of Trust. It was recommended by a colleague recently. Nothing to report on that yet, but I hope this is a good starting point for us all to learn. Next slide, Dave. So trust is a huge subject, but here in our sliver of the world in PKI, DigiCert, what our customers ask us to do is help them with the standards and defining what trust is. Secondly, helping them implement trust across their organizations globally and effectively. Now, PKI has become so prolific, in the organization now, that certificate lifecycle management, managing all of this trust, has become a huge focus for industry. And going back to that statement about C-level executives, extending that trust through supply chains and ecosystems, connected devices, connected partnerships, and so forth. It's a clear roadmap that's not easy to implement. But this is what DigiCert has been focused on for 25 plus years. Next slide. So DigiCert has 2,000 employees, and we're a global organization, and we've been focused on establishing trust and being a part of those standards bodies and working with both the standards, industry, governments, agencies, standards bodies, as well as our thousands and thousands of customers, including 97 of the top 100 banks in the world. And so we've been through this journey, and what our customers tell us is that DigiCert builds solutions that just work, right? And we might not have the flash and glamour of other companies, but we have been very focused on getting it right when we provide products. And so now we're moving into these new frontiers of managing trust and extending trust. Next slide. So before I turn it over to Dave, just a quick introduction. Dave lives in New Ross, a little hamlet in the county of Wexford in Ireland. This is about 2 hours south of Dublin. Dave would not tell you anything exciting about himself, except that he's the bad golfer from Ireland. But notably, the New Ross, he reports, is the ancestral home of John F. Kennedy's grandfather. So I know you're going to enjoy hearing from Dave today. I really enjoy working with him, and so will you as well. So let me introduce Dave Roche from Product Management here.
Thanks, Jason. Yeah, and I promise it, even though, you know, the Kennedys hail from where I'm from, I'll keep the politics out of it and stick to the cybersecurity. Okay, so we're going to jump in and talk about some best practices around DevSecOps, and a good place to start in that regard is to explain a little bit about what DevSecOps means, right? That we're familiar with DevOps, we're familiar with development, with operations, and there's a level of maturity in organizations which varies from basic development to full-on agile with automation and security adopted, and typically organizations fall somewhere in the middle of that. But the phrase itself is reasonably self-explanatory. Security as part of the DevOps approach to the software supply chain. But one thing I do want to call out is the secret and silent partner in that process, and that is automation, right? And we will see, and I'm sure a lot of you on this call can resonate with the fact that automation is becoming critical to your operations itself, and how that helps you to stay secure with your development processes. And therefore, what we want to keep in mind as we go through all of this is where security is, whose responsibility it is, and where it is. And essentially, it is an overlay across that DevOps process. And of course, Agile is the de facto method under which now we are all striving to deliver software faster, with feature-led deliverables, as opposed to the waterfall type approach that was the case in years gone past. Also, security is for everybody. So, and that doesn't just mean down to your developers or your release folks or your DevOps or whatever it is, and however it is that your organization structure that. All of us in an organization are responsible for doing the right thing, being vigilant, even with regards to phishing vulnerabilities and challenges that come into our email from day to day. And of course, the way to round that off is to say that security is everywhere. It's throughout all parts of that process, whether it's coding, whether it's release, whether it's build, whether it's post-release, or throughout the operation of that software and the life cycle of it itself. And again, this is a familiar graphic that you'll have seen over time, and it talks about really the sequential nature in which when you are trying to deliver software, whether that is new software or whether it's software that you're iterating on top of, that typically there is a sequential nature to it, right? Which goes from planning to coding all the way up to that software being released and in operation in the wild. And therefore, it is at each of these stages of that sequential process that you need to ensure that the security part is also incorporated into the development and the operations. Again, and this one is again a familiar graphic around the process and why the process is cyclical in nature. So the software itself being agile, it is being iterated upon all of the time. So consider the previous process, which was sequential, and you just repeat it over and over again. But therefore, again, the best practice around that is that when you are walking through these processes, and parts of them will be automated and other parts won't, that you ensure that you're implementing security best standards, whether it's in terms of your compliance and your InfoSec practices that are to be adhered to across your organization, whether it's in your coding, ensuring that your code is being statically analyzed, checked for vulnerabilities and threats, whether it's at the signing stage, which is where you're applying that digital shrink wrap around your software, so that when it leaves the bounds of your organization and lands within your customers, that it hasn't changed, that hasn't been anything hasn't been impacted or embedded in it, or change, or that somebody else hasn't injected some kind of malware into that. And then, of course, in terms of testing as well, that's probably traditionally where security has always been stronger. But again, not to be overlooked. Of course, there is a series of best practices around that, which you can implement using tools or services or practices which are well known. So I think at this point in time that we're going to raise a poll. I apologize. I think it says poll 2, but I might have skipped over poll 1. If that's the case, we might just launch poll 1 at this time, which asks the viewers on the call here to describe your organization. And are you a software development house? Is it in manufacturing, government entity, etc., etc.? So please just take a few seconds, pick which of these best describes your company, and we'll show the results then very soon. Okay, so there we go. So we've got a lot of focus on software, and that's represented by the developer community. We have some industry body here as well, which is great. But the majority are in terms of DigiCert partners. Okay, so we have a healthy mix across all of those. Okay, so the next thing I want to talk about is around some of the headwinds associated with software development and how to secure your software supply chain. And what I want to represent in this slide here is that, and we could have had dozens upon hundreds of different graphics here, but the one that struck me the most was one that we used where in 2012, one of the first indications that malware was being signed and distributed to impersonate an organization and therefore bypassing that trust was over a decade ago. And things have got extremely sophisticated since then. But some of the old tricks are still some of the best ones. And that is still the case today. Some of the recent publications in the media around software security challenges are still based on keys which were copied from a web browser in the case of Hyundai. But also, of course, there is now more sophisticated stuff around malware injection at the time of build, vulnerabilities in open source libraries and base images, and container-based images, and all sorts of risks associated with that. So it continues to grow. It continues to become ever more complex. And one thing that is helping to increase the complexity around that is the evolution of how organizations are developing software in the modern age. And one of the things to talk about is, of course, that the speed at which software is now being developed with the use of CI/CD tools, Jenkins, your Azure, DevOps, pipeline services. There's dozens of those tools there. They are extremely helpful in helping to automate the process. Once you can set up jobs in which your libraries and code repositories are being monitored for commits, and when those commits are made, the software is being automatically built and signed and distributed without human intervention in that. Of course, cloud deployments is also on the rise and has been for quite some time, and that is introducing new attack vectors as well as new opportunities for these bad actors to try and infiltrate an organization's software supply chain or their infrastructure. And therefore, it's another thing to be considered as a point of vulnerability. Orchestration with the likes of systems like Kubernetes, of course, is a very modern way to develop and release software, whereby containers can be scaled and used to ensure that your software, which may be running in a cloud, can be scaled horizontally at ease with a simple set of orchestration rules and practices using tools like Kubernetes. But again, with the container approach, there isn't good standards around how to adhere to best practices for releasing containers. How can you prove that they came from a verifiable source? How can you prove irrefutably that they have not been altered and they are the best version that organization wishes for you to use? And then, of course, the other and final complicated element which is being introduced in the modern development ages is around the proliferation of connected devices. So all of these devices, which are in our homes, in our businesses, on our streets, they are now smart. They are running software, and that software or that firmware needs to be updated. And again, if that is not being done in a secure way, that has the ability for that device to be overtaken by a bad actor and therefore to be used in attacks that could be varying from DDoS attacks or just to brick the device or a fleet of devices. So again, another method of attack and just a consequence of the way in which our world is changing with all of these new technologies. And there is some regulatory headwinds as well. So the CAB Forum has proposed that on November 15, 2022, that the standard in which a private key protected against a code signing certificate for a code signing cert will now also need to meet the same standard as an EV code signing cert. So what that essentially means is that any of you who are doing code signing today, where your private key might be sitting on a build server or on a developer's desktop or multiple developers' desktops, will no longer be permitted when this new change has been implemented. Now, just a little bit of news on that. There has been some communication. DigiCert is the chair of the code signing CAB Forum requirements team, and Microsoft has proposed that this requirement or regulation is delayed until June of 2023 or later. DigiCert is supporting Microsoft in that. We identified macroeconomic challenges around how that impacts the CAs and the customers in terms of their workflows. So while this change it looks now is going to have a stay of execution until the middle of 2023. It is something that we still are strongly advocating that customers prepare for, and don't leave it till the last minute. So get ready now for this change so that when it does come about, you're compliant and it is not going to impact all of those software supply chain implementations that you've done to date. The other interesting development, and again, this is being driven more by government than the industry, is that NIST, in partnership with CISA and ODNI, have released a best practice guide for developers around securing the software supply chain. And while, again, it's important to state that this is guidance for now, I think we all can envisage that when this is guidance given by NIST, or sorry, the NSA, what tends to happen is that these guidance and these best practices make their way into the RFPs that government agencies start to require when they're looking for organizations to develop software for them. And then once that happens within government and public services, you'll start to see large enterprises also adopting that when they request and tender for services regarding software from third parties. So things like preparing yourself for software bill of materials, or SBOMs for short, and that essentially looks like the recipe for what is in your software. If it was a jar of tomato sauce that you would use on pasta, it would tell you the percentage of tomatoes, how much herbs are used, what preservatives, etc., etc. So it's a software equivalent of that ingredients label, which helps those that are installing the software to understand how much is made by the organization who's shipping it, how much is open source, what's the library based on, where's the vulnerabilities, where's the risks. Okay, so we're now on to poll question 3, it says on my slide, but we're going to go to poll question 2. And this one is about what you're interested in learning about Codesigning today. So again, a couple of choices here. Please indicate what resonates most with you, and we'll look at the results then. All right, so let's see what's of interest. All right, so a strong majority there about keeping up with industry trends, and I'm hoping that we can meet those needs for you today, because we're trying to keep with regards to what is coming, but also to talk about some of the best practices based on our experience with all the customers that we deal with, as Jason described at the start. All right, so then if we're looking at security and we're talking about DevOps, we need to consider what are some of the challenges around securing your software supply chain at speed in this agile type approach. And some of the things that you need to look out for, one of the core ones is around the release process. And the reason this one is pertinent now and important for everyone to consider is that it's not just about keeping your source code clean, for want of a better expression, where you're doing static analysis on it and making sure that all your container images, base images are the most current and the least vulnerable, and that the libraries you're using are also not containing any vulnerabilities or malware. But when you guys think about what happened with SolarWinds, This was about malware being injected after and during the build process, after the code was swept and ensured there was no vulnerability within that. So it was a during the build process activity whereby that vulnerability was pulled into the software just before the signing happened. So even though SolarWinds as an organization had signed the software, had made sure that everything was clean in their code base and there was no risk there associated with it, it was the process during the build that was the weakest thing. Some best practices around that is that one of the principles is around reproducible builds. That is whereby, like if you were trying to consistently bake a loaf of bread or make an apple pie, if you have two ovens in two different locations and both and two different people baking that bread or making that cake, if they have the ingredients, they have the instructions, and everything is equal, if they follow them clearly, both will produce the same product. And it's the same with software. If I am building a piece of software from a code base and Jason is doing so from his side and we're doing exactly the same thing, the software we produce will be identical. The hash of the software I produce will be identical to the hash of the software that Jason produced. So it's about consistency and being able to show that there's consistency during the build process, whether that's with different build servers, different engineers, different automations, and being able to compare those should give confidence that nothing is being injected during that build process. There's tools on the market which can help you do that. You can also incorporate some best practices around hashing and checksumming on your software, from moving from the QA process to the production process with the code base being locked down. So consider that, please, when you're working through your build process and as part of your security hygiene. Another critical one, and we touched on this earlier, and both being driven by the CAB forum making changes, and also some of the media reports that that happen on a regular basis, is that the protection of the private key, which you'll use to sign your software before you distribute it, is really critical. Because if you are not protecting that, it falls into the wrong hands, they can essentially impersonate your organization, right? They can build whatever software they like, inject whatever vulnerabilities and malware into it, sign it, and when it gets shipped, it's going to say, this is coming from your enterprise, and customers will trust it. And if they have by chance got those keys and the associated certificate with it before it's noted, they could be releasing software in your organization's name for weeks or months before it's even detected. And there is a cottage industry on the dark web whereby malware authors are purchasing keys and certs from those who are either acquiring them by impersonating companies and going to CAs and acquiring those certs, or by the theft of these keys and certs from organizations. One thing to consider, though, when you are doing this is that, of course, like the CAB forms say, there is a requirement to protect your keys in a FIPS compliant way. But FIPS comes in many different forms, right? You can store your private key on a USB token. You can purchase HSMs, but there's challenges around all of these different flavors. If you're using a USB, it's very difficult to do automation. If one developer has the USB token, then what happens when that person goes on holidays? What happens when that USB token gets lost down the back of the couch, like the remote control? So consider how advanced you are in terms of your build process. Are you doing automation? And if so, then you're going to more than likely look at solutions like a Codesigning solution or a key management service for key protection. And again, make sure you get the ones with the FIPS compliance there so that you are you are in keeping with the future requirements that Codesigning is moving towards. In terms then of other things to consider across your software supply chain is organization level controls, right? So this is not just in terms of signing, but your coding standards, the certificate hierarchies that you're using, the processes that you use in your build processes, and how to ensure that is consistent and repeatable. So work to develop practices within your organization that reduce the risk of vulnerabilities or malware being introduced at each of those different sequential steps that we talked about during the software development process, right? Everything from planning to coding, right down to build release automation or an operation. Another very good practice to consider is to separate the duties of your users. Even if you're working in a DevOps type way, whereby many people are doing many jobs, the principle of dual control or M of N is critical in that regard, so that you remove the risk of one person within your organization having the godlike ability to commit, build, sign, release software without any other person in the team having an interaction regarding that. I know that some of you may think about that. You may think, well, actually that sounds efficient from an operations perspective and from a release perspective, but it's also extremely risky. So while we work now in a more DevOps and DevSecOps way, whereby not all the teams are as siloed as they used to be, you can still introduce controls around which parts in that process should be dual controlled or M of N, to prevent one person who could go rogue or who could be compromised for one reason or another, and therefore that person is a single weak link in the chain of your organization. And then the final piece is really around the InfoSec type controls that your organization would like to roll out across all of their organizations and development, right? So if you're in terms of algorithms, what is the best algorithm to use for a piece of software? Is it going onto a device, which is a connected device that has, has a very limited memory? Then you may be looking at one of the curves because they are smaller, they run faster rather than RSA. In terms of standard code signing, it might be the opposite of that. Again, also looking at things like whether or not software needs to be trusted in a public type way, or is it going into a private ecosystem under which you have the ability to restrict how that is being tested. So consider all of those challenges, all of those best practices from an organization perspective, and then ensure that those are rolled down to your users, that those are being adhered to, and that you're able to block some human error by putting controls in place to prevent users from doing the wrong kind of thing. So I think we might now go to our poll tree before we get to the last piece of this. And yeah, so if we can see the last poll, please. Yeah, and it's a good time to ask you, because we talked about some of these things previously, and maybe now is a great time to ask that. So what is, hard for you and your organization with regards to code signing, or sorry, securing your software? All right, let's have a look. Okay, so wow, this is really even. And I think that speaks volumes, because really there isn't a good choice here. And I can resonate with all of these, even within my own role within DigiCert, that there is the complexity, and there is challenges around organizational commitment, because there's competing priorities out there. And of course, being an expert on it is not something that comes naturally. You got to work at it. You listen to Jason and his reading list, and it's every day is a school day. We're always learning. All right, so let's move a little bit in a slightly different direction now, and just talk about, in the context of everything we've talked about, what are good practices to introduce into your supply chain to protect the code signing part of your software deliverables. And a really good practice is around doing hash signing as opposed to binary signing. You can do that because it's very quick. Your intellectual property is not leaving your premises, and it has the same effect. So you can do this with key management services and with code signing solutions, whereby, and also with your HSM implemented solutions to a degree as well, because really the full piece of the binary is not being shipped across the organization or to a vendor that you're working with. Some other ones to talk about are the account level security controls. So, document and put tight controls around the certificate lifecycle so that that's consistent. Make sure the right teams are getting the certs from public or private, and what validity those certificates are. So if you have devices which are going to need to be trusted in the field for a long time, you should be considering private trust in an ecosystem whereby you can have long life code signing certificates that are specific to your organization, for example. Algorithms we talked a little bit about. Pick the right algorithm for the right type of product, the right type of software, and ensure multi-factor authentication for your users to be able to identify themselves, so that they cannot be easily faked by some imposter or somebody who has come into possession of one of their credentials or has access to their device. So OTPs, etc., which are then on smart personal devices like mobiles, are a great way of ensuring that somebody can't be easily impersonated. Private key protection we talked about. Pick the right one for you. If you're into automation, the token might not be the right approach. If you've got a fleet of HSMs, that's great, but do consider that those are going to become out of warranty over time. They don't perform as good as they did when you purchased them, and they are expensive to maintain, as well as, of course, you then become responsible for maintaining the software and the firmware on those devices, and it's one more thing to consider. And role-based access around the duties that your users are permitted to do, and how you administer that those capabilities to your user with an ease that will require you not to have a master's degree with Stanford to be able to do that. So what I'll present to you now is that from DigiCert's perspective, we believe we have a flexible solution which will help you to adapt what you're doing today and to work with what you're doing today to implement all of those security practices with an off-the-shelf solution, which can either be something you use in a software as a service type way, or if you really would like a more dedicated experience, that you can take it and deploy it in your own data center or in your own private cloud and run it in a dedicated way. We call it DigiCert Secure Software Manager. It resolves a lot of the challenges around code signing that we spoke about. The keys are born within the service. They are FIPS compliant. They align perfectly for continuous integration, continuous development, so that automation is practical and possible, but with also the controls of multi-factor authentication wrapped around that. Because it's a code signing solution and the keys are in the service, we have the benefit of being able to track and monitor all the activities that your users are doing, whether that's creating new keys and certificates, or whether it's the users who are doing the signing. And by user, I could mean this is a service user, like a build server somewhere, automatically kicking off the signing process because some code was committed by developers in a different part of the world. The policies that we can also enforce in addition to that are the granular controls around what the user can do. So we have role-based access, so you can separate your administrators from your signers from the user that is just a build server user. And we can introduce very specific controls around that allow for approval flows, and that allow for your InfoSec security practices to be implemented. So again, when I talked about earlier about certificate validity and talk about algorithms like RSA and ECDSA, you can set up teams of users that are working on specific products, and you can set rules associated with that team, which says, you know, these users are working on commercially distributed software across the web. They're using RSA certs, public trust, code signing certificates, etc. But another team are working on software that's going to go onto devices in the field. The devices are challenged in terms of capacity and memory. We'll use Edwards curve algorithms with long life private trust certificates chaining up to a dedicated route owned by the organization. And the icing on the cake around that is that people are always concerned in TLS and PKI and code signing about the certificate, right? The certificate will expire. What do we do? How do we remember that? What's the practices in place? Well, the beauty of a solution like ours is that the key, because it's a record within the service and the certificate is the same, we're able to offer auto renewal flows around your certificates right out of the gate. So that means when you set up your key and your cert, that we have practices in place that will auto renew that certificate without you needing to click on anything, right? So it is the first and the last code signing certificate that you will ever buy or ever need to buy. I'll finish then before I go back to Jason and we get to some Q&A and some next steps. Just to briefly talk about a case study with a customer who has purchased Secure Software Manager to solve for a lot of their problems. And some of their challenges came out of COVID, but they were challenges that fit today's modern work from home, work remotely, or that spend time during the office and at home for the developer community, which is, of course, something that most people appreciate, the flexibility around the work-life balance. And the challenges that this company had should resonate with a few of you. The developers were all not in the office. They needed to sign drivers, so they needed EV code signing. And the only quick option that they had to do so was the token. And therefore, you know, that didn't scale very well for a developer team. They were going to have to require all developers to have tokens. And of course, it broke automation, because when you try and automate and your key is on a token, what your build server is going to say is, what's the token's PIN, right? So that means that the automation process was broken. You can see here that the technical director of the organization, had concerns around the tokens, but also had concerns around the automation and the consistency, because they were in a very agile approach and the frequency of the releases that they had. So this case study in full is available on the website, and I hope we'll be able to share the link with you as a follow-up for this, so that you can read how we helped DeNA to ensure the automation was adhered to in their organization, and help them to ensure that the security also was factored in as well. So this takes us to a couple of roundup slides from Jason, and then we get to some of the Q&A. So Jason, I'll hand it back to you just to talk us through this.
Perfect. And we'll be answering those questions in about 1 minute, folks. So Secure Software Manager is part of a more unified approach from DigiCert to provide a centralized console for delivering PKI solutions within your organization. And again, going back to the certificate management challenges of the the modern age. Next slide. Just want to stay on course here. Yes, a couple of great continuing events coming up. Next month, we'll be talking Zero Trust on October 12th, and we have a compliance webinar coming up, navigating the new OV code signing requirements, later this month on the 27th. So if you do not have access to links to register, contact anyone on our team, and we'll make sure that you get set up. Next slide. So we do have a simple solution that many of our customers are jumping on board with respect to getting, kind of that minimal viable product on board within your organization. And for, basically $1,000, you can get a starter pack for Secure Software Manager that provides all the capability in a tight license format. So, reach out to marketing or sales, or, find us, and we'll tell you about that. And it's something that, again, a lot of companies are just putting in place to have the initial solution ready to go, and that they can grow into over time. And next slide, Dave, I think that's it. Great. So a couple of really intriguing questions came in through the Q&A.
Yeah.
First question is a two-part question, Dave. Part A is, are the CA browser forum guidelines for code signing recommendations, or she wrote technical constraints, but maybe that's a requirement versus recommendation. And the part B is, does the browser actually know if keys are generated in an HSM or not?
Yeah, so good questions, and very pertinent ones. So the first part of two-parter is that these are a requirement, so it's no longer a recommendation. Once this ballot passes and the date is met, a CA such as ourselves will not be able to issue you with a certificate if the key has been generated outside of a FIPS compliant device. And to answer the second part of that, technically, does the browser know? So being incorporated into the flows under which now you choose a provisioning option at the time of placing your certificate order means that the organization, have to attest to where your key is stored, and that you're adhering to those processes. So in the likes of DigiCert, if you opt that you want for a token, we will provide you with a token. If you require a HSM, if you say you have a HSM, then we'll be seeking from you an attestation to assure us that you are what HSM you're using, that it meets the standards, and that you are adhering to that. So the onus is actually on the organization to prove that. And if the CA is not having a great confidence in that regard, then you may find that your orders are not going to be processed because the CA is not regulated to do so if the confidence is not there.
Thank you, Dave. Our next question is, what are the best practices to protect private keys with respect to cloud hardware security managers? usually the cloud service provider is offering a cloud HSM?
Yeah, so what I would recommend in that regard is to do your homework on the cloud HSM service. Make sure that it is adhering to the FIPS standard, and that is doing so in the way that your CA will require it. So if you are using a Key Vault or an Amazon AWS KMS or Oracle or Dpod from Thales or one of those, make sure that your service you're using is compliant. Your CA may be asking you to prove that. And if you can't verify that and justify that, then again, you could be in a challenging situation where your order does not progress.
Thank you. And finally, Dave, does Secure Software Manager work with an existing in-house root certificate authority or existing sub-CAs?
Yes, a great question, and the answer is yes. So there's a couple of ways that the platform can accommodate that. So one way is that we can assist you by importing one of those, either the intermediate rather than the root, or the sub-CA, or we can also offer to sign a new intermediate or issuer in the chain, so that issuer is born within the platform, but that it chains up and is signed by a sub-CA or the root CA already owned by the organization. So that means that you keep your existing trust hierarchy, and that you can issue then automatically from the DigiCert1 platform, all under the controls of the Secure Software Manager workflow. So keys and certs are generated instantaneously, but your existing roots and chains are respected, and everything links up to that.
Thank you, Dave. And the final question that came in through the chat interface is, after how many strokes do you stop counting your score on a given golf hole?
That's a good one. I would say that if you have to start taking your shoes and socks off, you're definitely in trouble. So yeah, keep to the fingers. 10 digits. That
was a crafty non-answer, Dave. Excellent. Well, anyway, thank you everybody for attending this webinar. We're just 3 minutes over our stated time of 50 minutes. Thanks for your time. Please look us up if you have any questions, or if there's something you'd like to discuss around Zero Trust, Digital Trust, or secure code signing.
Thank you. Have a good day.